We need to find the y-intercept, the x-intercepts, the equation of the axis of symmetry, as well as the vertex. Here are the steps to find the y-intercept. Pause this video to study them more closely. Here I've graphed the y-intercept at 0, 15. Finding the x-intercepts means to let the y value equal 0, or more formally, f of x equals 0. This means we need to find x. As you can see from the steps below, x is found by using the zero product rule, and we are looking for factors that multiply to give 0. So our parabola crosses the x-axis at -3 and also at the x-axis at +5. I've graphed those 2 points as well. The axis of symmetry is halfway between the two x-intercepts. So if we average -3 and 5, we will get that x equals 1. Somewhere along the axis of symmetry, at x equals 1 is the vertex. So what we need to do is to evaluate the function at x equals 1. We expect the vertex to be a maximum point because of the a factor here as -1. Here we've calculated the vertex substituting x equals 1 for the original equation and calculated that the vertex occurs at 1, 16. I've plotted the vertex and confirmed that it is higher than all the other points. Now I will use GeoGebra to complete the curve, just to confirm that my points are correct. Here is part B. Remember to pause this video to see the steps. The y-intercept is -12, while the x-intercepts are 1.5 and -4. The axis of symmetry is halfway between the two x-intercepts, so we average 1.5 and -4, and we get -1.25. This is the equation of the axis of symmetry, x equals -1.25. Now that we know where the axis of symmetry is, all we need to do is evaluate the function at x equals -1.25 to find the vertex. Well, that was complicated. The vertex is -1.25 at the y value of -15.125. This is a minimum point. Here it is graphed using GeoGebra. Unfortunately, you can't pick out the details that you really need. I'm going to switch to Wolfram Alpha to see if I can get more detail. I've typed the equation in Wolfram Alpha, and it's graphed the parabola for me. I can pick out the x and y intercepts as I had calculated them. They're not exact, but it's close enough and it does confirm my answers. However, to be able to use Wolfram Alpha properly, you're going to have to understand some of the concepts. So I've asked Wolfram Alpha to minimize the function for me, and it has done that. It has given the minimum value of y as -121/8 at x equals -5/4. That's the same as what we got before. -121/8 becomes -15.125, and the -5/4 is -1.25.